I didn't expect 10 people, guys.
Okay, so you guys remember on Monday, I think you just started road is Monday, right? On Monday, remember we talked about static electricity. Remember I said that if you bring two different kinds of materials together because they have different atoms, they can steal their electrons and charge up things. And then we did a bunch of experiments with charging up. And then you remember when you rolled the pop can and I said that in a conductor, in metals, the electrons can hop from one atom to another real easily. So that's going to lead in, we're going to talk about electrical circuits today, which is making those electrons in a conductor move around to make a current flow. And so Dr. Santiago here is an electrical engineer, and so he's going to teach you about circuits.
Okay, can anybody explain to me what electricity is? Go ahead.
Electricity is a sort of power, like, it also comes from lightning, because
You're right.
like something to push that electricity out of the car.
Right. It's like a pump pushing the electrons. How about, and you have an idea?
Yeah, I think electricity could be like a type of energy that can power stuff.
Good. Energy. So when you see things move, all right, that means it requires energy.
Yeah.
Okay? So I'm going to demonstrate here what is a water, because the electrons are like water. Okay? And what's going to cause to move the electrons?
Electricity.
Electricity, but where does it come from?
Water.
No. It could, because of a dam, because a dam turns the turbines, yes.
Electricity comes from the sky and like lightning and stuff.
We talked about lightning on Monday, that's what.
Yeah, that's okay. Yeah, that's part of it too. Because who discovered there's electricity in lightning?
We.
So what do you guys have to put in something to make the electricity go in it?
Atoms. Force.
Think about your Game Boy or something. What do you got to put in there to
Chargers.
make the batteries? Exactly.
So batteries provide the energy to move the electrons that are already there, all right, in a refrigerator. So I'm going to just show you this, and tell me what do you observe based on the water. Forget about this for now. Go ahead. Yeah. Right, and then did you see this? I lost my pipe. There's a pipe right here, supposed to put a pipe, and then I lost it just now. And then, that's a pipe, and it's supposed to feed it in. Yeah, if it starts to spill, I got this. But you can see the height, right? It gets higher and higher. And then what happens, it's gonna eventually.
What it's doing is hitting
Exactly. No, well, it provides energy to move the water. And that's what the battery does. It provides energy to move this motor, which acts like a pump.
That was for the filtered water machine.
Like the coffee maker or something?
Yeah, you're right. See, you're putting things together. So you can see this is a motor, correct? And it's pushing this back and forth, right? And it requires what? Energy. Okay? And it requires energy to suck up the water. And therefore, it's completing the circuit. So what reminds you of the word circuit?
Like things that you put in the car to make it drive or something.
Yeah, that's
What's
yeah.
another
like a
word
circuit.
that kind of
What's
sounds
a
like
yeah? Go ahead.
Like a circuit is like a gear.
Yeah, almost. You're getting there. You said say it again. Circle. You got it. Notice it's creating a circle. Okay, and that's what you do when you create a circuit. You have to create a circle. Okay, this is a resistor. Have you seen a resistor before?
Yes.
Okay, a resistor. Do you consider a toaster a resistor?
Kind of.
Yes.
Yes. Good. How about a light bulb?
Yes.
Yes, because what does it do? When you feel a light bulb in the old days, is it hot?
Yes.
Yes.
Yeah, because it's converting that into energy, heat energy.
It's dripping.
So, okay, it's dripping. That's okay, I got this. All right, does that make sense? Okay, so notice, is this a closed circuit or an open circuit?
Open.
Why is it open?
Because there's gas.
Where's the gaps?
Right
There.
Well,
No.
this is not a gap. This is
It's
connected.
a wire, it's got wires on it.
It's a closed.
It's not.
It's a closed circuit, right? I mean, it's an open circuit, but I can close it with what?
Battery.
Battery.
Okay? If I close it, what lights up?
The light.
The light. So if I turn it off, so guess what turns things on and off?
Battery.
Right, but there's a particular device, yes, a switch. So a switch is a special kind of resistor. So a switch, when it's on, let's say I put a switch here, I turn it on, right? That means the resistance is 0 or large.
Yeah, 0. No, live.
No, 0, because resistance prevents the current from flowing. Okay, so if I want to make this flow even better, I would make this a bigger pipe, and you get more current flow. Does that make sense? And then more current flow makes this thing go higher and higher. If I put this like 10 feet, this bigger current will go high. It's going to take a long time, because right now it's a small, right? Small current flow. But if I put a bigger pipe, and I make it bigger, taller, it's going to go just as fast now. Make sense? Okay. So the switch, this could be like a switch. If I break this and I put it this on and off, then this will turn it on and off. So like when you turn it on, resistance is what? 0 or large?
0.
0. If it's off, resistance is large. Because right here, have you heard the word infinity?
Yes.
Which means it's a very
Large.
large number, right?
Yeah.
So there's,
It's actually not a number. It actually keeps on going forever.
yeah, it goes forever. It's like a inverted, it's like a sideways 8, right? That's the symbol for
So here's
infinity.
what a switch would be like. So
Yeah.
if you had wires connected to each of these ends, this would be open, and so the electricity can't jump across there. But when we close it, now the electricity can go through there. So this is what a switch is doing.
And let me switch this off. That means the resistance is
Large.
large. If I turn it on,
Zero.
0. Good. So now you know what an open switch is
Closed.
and a closed switch.